Hello, class, and welcome to week 2. For this week's formative assessment, we're working with polar, nonpolar, and ionic bonds. So I want to go over to do a tutorial on this lab and go through different things that you'll be working with for this particular lab. For this one, in the first part, part 1, you're working with electronegativities, nonpolar and ionic bonds, and also polar bonds. And so read through this information. This gives you some background on electronegativities. This electronegativity chart looks like your periodic table, but the values that are given are electronegativities. And so what electronegativity is an element's attraction for electrons. And so the higher the number, the greater the attraction for electrons. The lower the number, the smaller the attraction for electrons. So metals tend to have lower numbers because metals like to donate their electrons. Nonmetals have higher numbers because they like to gain electrons. And then our semimetals or metalloids that are in the middle here, they're somewhere in between the metals and the nonmetals. Okay. But these numbers are what you'll need to do the calculations for the electronegativity differences. And so the difference when we take the electronegativities of two elements that are combined in a bond, we can determine if that particular bond is a nonpolar covalent bond, a polar covalent bond, or an ionic bond. So if the difference is 0 to zero point 0.3, then it's nonpolar. 0.4 to 1.7 is polar, and greater than 1.8 is ionic. When you're taking the difference, you always want to take the larger number minus the smaller number because you don't want a negative electronegativity difference. Okay. And so when we're looking at this, for our nonpolar bond, it's similar to this picture where you have your electrons that are kind of in a shared state, okay? And it creates that nonpolar bond, all right? It's more of an equal sharing of those electrons. In the polar covalent state, there's one element that has a greater attraction for the electrons than the other one, and it creates what we call a partial positive and a partial negative charge. This symbol here is the Greek symbol delta, and it means partial, and if it's a plus sign, it's partial positive. And over here with the negative sign is a partial negative. Depending upon the electronegativity difference, depends upon how great that partial positive or partial negative charge is. And then if it's an ionic bond, then the nonmetal is wants to gain the electrons, so it becomes a negative charge. The metal wants to lose electrons, so it becomes a positive charge. And so it's more of a separation of charges. With the polar covalent and the nonpolar covalent, it's still a sharing, equal sharing for nonpolar or almost equal, and then a non-equal sharing for polar. Okay, so that's to tell you a little bit more about those bonds. So when you go through the questions, okay, this first part, you're going to be asking questions or answering questions based on the electronegativities. So that's for questions 1, 2, 3, 4, 5, and 6. Okay. One thing I want to point out for question 6, there are boxes here, but not all these boxes need to be filled in. What you want to do is you want to classify each bond in each of the following molecules as nonpolar, polar, or ionic and put an X in the correct box. And so for O2, what you would do is you want to look at your values for oxygen. So oxygen is 3.5. And so there are two oxygens in that bond. So you take 3.5 minus 3.5 and you get 0. So if we get 0, then we know it's nonpolar covalent. So what you'll do, once you've done that calculation, you figure out it's nonpolar covalent, then you want to put an X in the box, okay? You're going to leave the other two boxes empty because they are not, that's not the correct classification for this bond, okay? So you want to only put an X where the correct classification goes, all right? And then for number 7, you want to answer the question based on your electronegativities. But then we get to question 8, and now we come to part 2 of your experiment, which is the lab simulation. So what you want to do is right click on your link here and you want to open the link in a new tab. This helps you to be able to read the instructions and do the lab at the same time, okay? And so when you click on it, you will get something that looks like this. You want to click play and you want to run, um, you can download the Java. I thought I already had it on here, but we'll download it. Okay, and then it'll come up like that. Otherwise, let me show you. If you run the compatible within the website, then it will come up. And it's coming up slowly. All right, and then it comes up. So you can use one or the other ways to bring up your simulation. All right. So then we go back and it's going to give us the instructions. So we drag the conductivity tester labeled A into the beaker of water, place the negative and positive electrodes into the water, but do not touch the bottom of the beaker. When the electricity is conducted by the solution, the light bulb will light up. The stronger the electric current, the brighter the bulb will glow. Okay. And so we have this conductivity tester. And remember, we don't want it to touch the bottom. So we have it here. So we have salt and you have sugar. So those are your two solutions that you're working with. Okay. And so it says that we want to click the salt shaker labeled B and drag your mouse back and forth. This will shake the salt into the water. As you add salt, pay attention to the light bulb on the conductivity tester. Continue to add salt until the shaker is empty. Record observations, then click remove the salt. Okay? You're going to do the same thing with the sugar. Okay? Then you're going to click on the micro tab at the bottom of the simulation labeled D to switch to a new simulation for part B. Okay? And so once you've done that, then you want to do the micro tab. Okay? And that's for this second part. And it's going to tell you step by step what to do in your micro tab. All your observations you want to place in the observation box. All right. And then we get to question number 10. So for question number 10, it says that you're going to use the Flynn MSDS search to look for sodium chloride and for sucrose. And so you're going to right click on this and open this in a new link. When it comes up, okay, you're going to have the Flynn Scientific Safety Data Sheets. You are going to click on the S for sodium chloride and then scroll down till you find it. And you want to do, where are we at? Let me get down to it. Okay. So you want to do the first one. You don't want all these others. So you just want sodium chloride. And it's going to come up and you're going to get all of this information, okay? And so you are going to fill in what's missing in your table. So for sodium chloride, which is salt, all right, you're looking for the melting point, solubility in water, electrical conductivity, and ionization, and whether it's covalent or ionic. Okay. And so you're going to look for that information. So I'm going to show you one of them, which is the melting point. So let's look for the melting point. And so it says here that the melting point is 801 degrees Celsius. So you're going to type in 801, and you don't really have degrees, so you could just put Celsius C, or you could put degrees Celsius written out in words. But if you just put C, capital C, I'm fine with that. Okay, so you're gonna fill in everywhere you see a box. So before, where you had all the little boxes, you didn't need to fill in all those boxes. You're just checking the correct box. But for this one, you actually have to fill in all of these missing boxes. So anywhere you don't see an NA, all right? So then we come down to question number 11. A data table is provided below with information on substances not tested in the simulation. Complete any missing information by looking up the MSDS sheets for each of the following chemicals. Okay, and so it gives you the name as well as the formula. And so just like we did for sodium chloride, you're going to do the same thing, okay, for each of these using this MSDS sheet, okay, or SDS. They've changed the name since this was written. All right. And so those, again, you're going to fill in every box that is empty. Okay. So all these empty boxes, you're going to fill it in with the missing information. So just to give you a heads up, okay, sodium chloride, remember, is salt. Sucrose is the actual name for sugar. And so that's how you'll look it up on the sheets. If you have any questions as you're going through this lab, oh, let me go through the last one. So, what would the simulation have shown if oleic acid was added to water? So, based on your information here, how would it look and how would it be different from sugar and or salt? So, you're going to explain that. All right. And remember, you always want to submit the quiz. If you start working on the assignment and you find out, okay, I don't have enough time to complete it all in one sitting, the system will automatically save what you've done. As long as you don't click submit, you're good. Okay, just make sure that once you've completed all 12 questions, that you do hit submit quiz. And if you have questions, let me know. Have a great day.